Architecture of mobile device. Think of a mobile device as a layered system, just like a building, right? Top layer contains apps we use, right? Middle layer contains system softwares, right? Bottom layer contains physical parts, right? First one, hardware layer, right? Bottom layer, right? Okay. This is everything we can touch or that physically exists. The main components of hardware layer. First one, processor. The brain of the phone, right? Memory. We can divide memory into two types, right? RAM and storage. RAM running apps, storage apps, photos and videos. Next one, sensors. Accelerometer, gyroscope, camera, fingerprint sensor, likewise, right? Input devices, touch screen, microphone. Output devices, screen, speaker, right? Battery and power unit. Without hardware, no mobile device, right? The next layer is operating systems. This layer controls the hardware and manages resource. What are the example? Android and iOS, right? What are the responsibilities of an operating system? Memory management, process scheduling, file system, power management, and security, right? The OS is like a manager between hardware and apps, right? The next layer is middleware or runtime layer, right? This is the helper layer. What it provides? APIs for camera, GPS, sensors, right? And libraries like graphic, media, networking, runtime environments, examples Android runtime, iOS framework, right? Apps don't talk to hardware directly, right? They go through this layer. The last layer is application layer. This is the top layer of architecture of mobile device, right? This is what users actually see and use. Example, WhatsApp, Instagram, mobile games, banking apps, right? Apps use APIs. Apps run in a sandbox for security. Remember this point, right? Mobile applications cannot access directly because the OS acts as a secure intermediary, right? And managing and abstracting hardware access for reasons of security, system stability, and compatibility, right? Why direct hardware access is a security risk? If apps accessed hardware directly, malicious apps could read our camera, mic files secretly, right? Apps could steal data from other apps. No permission control, system could be compromised easily, right? That's why the OS enforces permissions and isolates apps, sandboxing, right? Architecture of Android mobile device, right? Think of an Android device as a layered systems like a cake, right? Each layer depends on the one below it, right? This is the architecture of Android mobile device, right? First one, Linux kernel in Android, right? This is the foundation. It handles hardware. It acts as a bridge between software and hardware. It handles process management, memory management, device drivers, right? Security and power management. Kernel handles networking and vast array of device drivers, right? It uses Linux 2.6 kernel, but it is the oldest one, right? No native windowing system, no glib library support, right? Modern Android mobile devices use Android common kernels, right? Which are based on specific, stable, long-term support versions of the upstream Linux kernel with additional Android specific patches, right? Apps never interact directly with hardware, they go through Android layers, right? The next layer is hardware abstraction layer in Android, right? It provides standard interface so higher layers can access hardware without caring about specifies, right? Example, camera hardware abstraction layer. Let's apps use the camera, right? Audio HAL. HAL means this, right? Okay. Let's apps play music, right? It makes Android flexible across devices, right? The next layer is Android runtime or core libraries, right? ART means Android runtime, right? It executes our app's code, right? It uses .dex, it means Dalvik executable, right? Files compiled from Java or Kotlin, right? Just-in-time and ahead-of-time compilation for speed, right? Core libraries provide essential Java APIs, data structures, file input-output, network access, graphic database handling, right? We have local libraries. Includes Bionic Lib. It's a custom lib implementation and optimized for embedded, right? And function libraries, native servers, hardware abstraction libraries, right? Let's talk about Bionic Lib, the BSD license, right? The code path is small and fast. It is very fast and small custom pthread implementation. It is built-in support for specific Android service important system properties, right? It does not support some POSIX features. GNU lib is not compatible, right? The native code must rely on the Bionic to compile, right? The next one is function libraries. First one, WebKit. It based on open source WebKit browsers, right? In full view rendering, full support CSS, JavaScript, DOM, Ajax, right? Support single and adaptive rendering, right? Next type, media framework. Open core platform on packet video. Support the standard video, audio, still frame format. Support hardware and software encoder plugin, right? Next type, SQLite. A lightweight transaction data storage. The backend data store of most platform, right? The next one is native servers. We can divide it into two types, Surface and Audio Flinger, right? Surface Flinger. It provides system-wide appearance, combine all the appearance of rendering into the frame in buffer equipment, right? It can be combined with 2D and 3D appearance and multiple application appearance, right? Can use the OpenGLES and the 2D hardware accelerator, right? Double buffer system using page flip, right? Audio Flinger. The output of the audio equipment management, right? Processing of multiple audio flows to the PCM audio output path, right? Audio routing to each output. Dalvik VM, a special Java virtual machine designed to run with limited system resource, right? It is memory efficient. Register machine vs versus stack machine, right? Fewer instructions, faster execution, right? Running multiple VMs more efficiently, right? .dax Dalvik executable, right? Java class files are converted into .dex files that Dalvik executes, right? Java bytecode is converted into Dalvik bytecode during this process. The next layer is application framework layer, right? It gives developers ready-to-use building blocks. Activity manager manages app lifecycle, right? Content provider share data between apps. Notification manager send alerts, right? Resource manager access images, strings, layouts, and etc., right? It makes app development faster and more standardized. The last layer is application layer, right? The top layer where your apps live, right? Each app runs in its own sandbox, isolated to security, right? No, isolated for security, right? Example, system apps, phones, settings, messages, right? User apps, Instagram, YouTube, custom apps, right? Okay, why this architecture is smart? Security, portability, efficiency, modularity, right? Okay. If you get something from this video, don't forget to subscribe us, like, comment, share with your friends. Bye bye.